Alrighty, well, Hafiz, Eric, this is for you. You guys asked me a great question. I looked into it, and there you go. So how secant line and tangent line relate to trig. I looked it up, made sense of it, and now I can explain it to you. All right. So picture a circle. And if we drew a random angle, an arbitrary angle on this circle, say there, so that's an arbitrary angle. All right. Now remember that the horizontal distance is represented by cosine of that angle, and the vertical distance there, vertical displacement, is represented by the sine of that angle. All right. Now remember that this is a unit circle, so we'll just call this, the hypotenuse there is 1. Well, if we extend this line outwards, right, and we make a triangle from this point to the origin, and we extend straight up, like so, straight that way, okay? Now remember that this length from here to this point is also 1 because it's a unit circle, right? Well, what's this length from here to here? What's this, which we'll call x? What's this? All right. Well, if we look at this large triangle that we created, we could write it in terms of cosine. So we can say cosine of this angle is going to equal adjacent, which we know is 1, over the hypotenuse, which we don't know what it is, so we'll call it x. Multiply x over, we get x cosine theta equals 1. Divide by cosine theta, we'll look at that, we get that is represented by 1 over cosine theta, that distance from here to here, which 1 over cosine is equal to secant theta. So this right here is actually secant theta. And notice that this line, secant theta, intersects the circle at 2 points. And that's how the secant of a line is related to secant in trig. All right. What about tangent? All right. Tangent, remember, intersects the line once. So let's look at this large triangle again. So let me highlight it. Look at from here to here to here. I don't know, you know, if you see this in red. And now instead of taking the cosine of that arbitrary angle, let's take the sine of that arbitrary angle. So if we take the sine of this angle, that's opposite, which we don't know what this is, so we'll call that y, over hypotenuse, which we now know is secant theta. We found that. Right? Multiply that over, you get y is equal to sine theta secant theta. Remember that secant is 1 over cosine, so this is now sine theta over cosine theta. Well, look at that. That is tangent theta. So thus, this line right here is tangent theta. And notice that this line, this distance, if we were to extend this distance outwards, only intersects 1 time. And that's how tangent line and secant line come from trig. Great question, and now I appreciate you sharing that with me, so thank you.